Welcome to Science Manthan. I am absolutely thrilled to have you here today. In this explainer, we're going to embark on a really fascinating investigation into the foundational physical science of everyday objects. Basically, we're going to decode the very building blocks of the world that you and I interact with every single day.
Okay, so I want you to act as a material detective with me right now. Seriously, just take a second and look around the room you're sitting in. You might see a window, maybe a desk, a coffee cup, or a soft chair. But have you ever actually stopped to wonder why that window is made of glass, but your chair is made of wood or fabric? Like, why isn't the window made of wood? I know it sounds like a silly question, but the answers to that lie in the incredible, highly specific properties of the stuff that surrounds us.
So let's dive right into this. Here is our exact roadmap for today's investigation. We'll start with objects versus materials, then look at the power of classification. After that, its appearance and luster, the hardness scale, and finally, how materials handle light.
All right, kicking things off with Section 1, Objects versus Materials.
To get started, we really need to establish a crucial baseline here. What is a material? Well, it's simply the substance used to create an object. Think about the books on your shelf, the chair you're sitting on, or that plastic water bottle on your desk. They all drastically differ in shape and size, right? But each of those objects is constructed from one or more materials. And here's the thing. Those materials aren't just picked out random. They are chosen very specifically for exactly what that object needs to do.
And it's pretty cool when you think about it, because we can clearly contrast these items. Some objects are made of just one single material. Think of a glass jar or a solid wooden baseball bat. But depending entirely on what the object is meant to do, it might actually need multiple materials combined to work. Take a standard pencil. It's not just one material. You've got wood for the body, graphite for the core so you can actually write, a little band of metal at the top, and of course, rubber for the eraser. It's multiple materials all working together to pull off one single job.
Moving right along to Section 2, the power of classification. This brings us to how we actually make sense of all these hundreds of thousands of different substances in our world. You can kind of think of classification as our scientific superpower. It's the act of arranging materials or objects into groups based on common properties. By grouping things together, it helps us compare, study, and organize everything way more efficiently. Instead of looking at a million random, chaotic items, we can just look at a few distinct categories.
And grouping isn't just some high-level concepts for scientists in white coats, We literally rely on this every single day. Think about walking into a grocery store. The fresh produce is all in one section, the dairy is in another, and the cleaning supplies are completely separate. Or even just look at your own home. You keep your clothes in the closet and your pots and pans in the kitchen. We classify things constantly, so similar items are kept together for easy identification.
Now for Section 3, appearance and luster.
So, what's our first major physical clue for classifying materials out in the wild? It's surface appearance. When you're playing material detective, your eyes and your hands are absolutely your best tools. Just by looking at whether a surface is shiny or dull, noticing its color, or feeling its texture, we instantly gather vital clues about its identity. Different materials just have vastly different appearances.
Which leads us to a great key term, lustrous materials. These are simply materials that have a shiny surface. So, when you hear the word luster, you should immediately think of metals. Gold, silver, copper, iron, the vast majority of metals belong right here in this shiny category. But here is a really surprising fact for our detectives. Exposure to air and moisture gradually reduces their shine. Just because something is dull doesn't necessarily mean it isn't metal. Metals can actually tarnish and lose their shine just from sitting out in the environment. And on the flip side, some non-metallic materials can be painted or polished to look super shiny. So while appearance is a fantastic first clue, it's not exactly a foolproof identifier all on its own.
That brings us to Section 4, the hardness scale. Since we know we can't just rely on looks alone, we have to ask, well, how do these materials react to physical force? Materials differ drastically in their resistance. Hard materials are those that strongly resist scratching and compression. You can't easily squish them or carve into them. Soft materials, on the other hand, they can be compressed, bent, or scratched much, much more easily.
And this is a brilliant way to illustrate how we should actually think about hardness. Hardness is a comparative property. It's not absolute, it exists on a spectrum. So on the far left, you have a sponge, which is super soft and really easy to compress. Then in the middle, you have a piece of rubber. Now, rubber is harder than a sponge, but it still has some give to it.
Then way over on the far right, you have iron, which is incredibly hard to compress or scratch. So is rubber hard or soft? Well, it depends entirely on whether you're comparing it to the sponge or to the iron.
Let's move on to our final stop, Section 5, How Materials Handle Light. This is one of my absolute favorite ways to classify things. Let's see how these materials behave when light hits them. First up, we have transparent materials. These are materials that permit clear vision straight through them. They allow light to pass completely through without scattering it. So, when you look through a transparent material, you can see the objects on the other side with absolute perfect clarity.
Next up on the spectrum, we have translucent materials. These allow only partial passage of light. So some light gets through, sure, but it gets scattered in the process. And because of this scattering, the image on the other side becomes totally blurred or frosted. You might know there's a light source or an object sitting right behind it, but you just can't make out the fine details. And finally, we have opaque materials. You can think of opaque materials as a total roadblock for light. They completely block any light from passing through. You cannot see through them at all, no matter how hard you try to look. So synthesizing everything we've just learned, you can really see how these exact light-handling properties dictate everyday engineering. I mean, you want spectacles to be transparent, obviously, so you can see clearly. But you might want a bathroom window to be translucent, letting in that nice sunlight but maintaining privacy by blurring the image. And you definitely want a cardboard box used for shipping to be completely opaque to protect and hide whatever's inside. Every single choice is intentional. So as we wrap up today's investigation, I want to leave you with this question. How does understanding these physical properties change the way you view the objects around you? Hopefully, you'll never look at a simple wooden chair or a glass window quite the same way again. Like, subscribe, and share for such more science-related videos. Also, drop your comments and queries in the comment section. We will catch you in next one.